Hi everyone. In this video clip, I am going to discuss the trigonometry functions with all of you. Now, we will discuss more on the graph sketching part. Now, let's look at y equals to sine x first. Now, let's sketch the sine graph. So when we have y equals to sine x, now we need to know the basic graph of sine x. So for sine x, it starts with 0. All right. When before that, we have to divide our x-axis into 4 quadrants. Okay, into 4 quadrants. The important angle will be, this is our unit circle. The unit circle basically is the circle with center O as the with the origin as the center. So whereby this one represents 0 degree, okay, and this is 90 degree at xy axis, and on the negative side of the x-axis will be 180 degree, and on the negative side of the y-axis will be 270 degree. When we move a whole turn, we come back to the positive side of the x-axis, which is also 360 degree. So based on the unit circle, we know that sine x start with 0, okay, and then 90, 0 degree when it is at 0 degree. So we divide the x-axis into 4 quadrants. This is first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so with this, we will have the important marking for the x-axis that will be 0 degree, 90 degree, 180 degree, 270, and then 360. Okay, remember these 4 basic quadrants. Now, of course, when we sketch the graph, we will divide the x-axis into 4 quadrants first. Don't label yet. Why? I'll tell you the reason, okay? Let's just look at the basic sine graph, okay? Sine x graph, the maximum, when it is 0 degree, we have the sine 0 is 0. Sine 90, it is 1. So let's mark down 1 here. 1 is the maximum value that that the sine x graph can go to. So when it is 90, we get the maximum value, come back to 0, and then it will go towards the -1, okay, and then back to 0. So we will have the basic of sine x graph that look like this. This is a complete oscillation of the sine x graph, okay? We have one mountain and one valley. Now, remember this basic graph of sine x. What about the cos x? Y equals to cos x. The cos x will be the opposite of the sine x. So when at 0 degree, when sine x is 0, cos x will take the maximum and then come to 0, and then goes to the negative maximum, come back to 0, and then go to the maximum. So the graph will look like this. Now, sine graph and cos graph, they actually look exactly the same if we continue. Okay, we will have the graph that goes like this. Same thing goes to the negative part, the negative part. Just that the cos graph is 90 degree a bit later than the sine graph. Okay, so in this case, remember the basic graph for sine x and cos x first, whereby sine x start with 0, cos x start with the maximum 1. You can remember this way, sine, if you know, sine stand for CFAR. CFAR in BM means 0. Okay, so remember sine x, CFAR, 0, start with 0. And cos x will be the opposite, it will be maximum. Now, what about the cos x, tangent x graph, okay, when we have y equals to tangent x. Now, tangent x is equivalent to sine x over cos x. So we will have a different graph. So let's just draw it on the separate graph. Okay, let me put them together, side by side. Oops. Okay. So that we can compare. Yeah? We can compare easily. Okay, too much. Okay, so when we have this, now again, we have to label our 4 quadrants first. 1, 2, 3, 4. And since this is the basic tangent graph, so this one will represent 90 degree. Now this will be the asymptote. For tangent graph, we will have asymptote. Why? Because tangent x equals to sine x over cos x. And then we will have at the time whereby cos x, okay, we don't want cos x to be 0 because when cos x is 0, we will get tangent x undefined. So when is it cos x 0? By looking at this original, the cos x graph. Cos x 0 when it is at 180 degree. Okay. Oh, sorry, cos x is a red graph. It's at the 90 degree and also 270 degree. Therefore, we will have the asymptote. Asymptote is the line whereby our graph will never touch. Okay. Now, so with that, our tangent x graph will start with 0 because when sine 0 is 0, so tangent x will also be 0. All right. So we will have the graph that goes like this. It will never touch, no U-turn. Okay, same thing goes to the rest, go down and come up again. No touching. And then this side, for the 4th quadrant, it will be same as the 2nd quadrant. Okay, so that will be the standard graph for tangent x. Now, next, we shall go to the transformation of graph. That is the very important concept that everybody should learn. Okay, so for the trigo graph, okay, I shall use sine x as an example. We will have this a sine bx plus c for your syllabus. Okay, now what does a representing? A represent the amplitude of our trigonometry graph. You look at the basic sine cos graph, our sine x is 1 sine x, cos x is 1 cos x. That's why your amplitude, see, your maximum displacement from the mean is 1 unit. Okay, so when we have 2 sine x, then this whole thing will stretch higher to achieve the maximum point of 2, and the minimum is -2, as long as our amplitude is 2. What about the B? B representing the number of turns, the number of complete oscillation. I shall use this complete oscillation in 2 pi or in 360 degree. That means for our standard sine x graph, the B value here is 1. That means you will see 1 complete oscillation in 360 degree. That means it will, from 0 to 360, you will see this, for cos graph, you will see this half mountain, a full valley, and another half mountain. It's like a valley between 2 mountains, whereby the sine x, sine 1x, so you have the 1 mountain and 1 valley. Okay, so that is the oscillation. Now, what about C? C will be the shift, the Y shift. Okay, the shift of the graph in, I should say, vertical shift. Vertical shift of the graph. Now, let me show you the example. Okay, for y equals to 2 sine x. Okay, Now, by using this, okay, let's move it. Okay, so for 2 sine x graph, same thing, yeah, we divide the x-axis into 4 quadrants first, right? And then for sine x graph, look at the sine x graph first. This is the amplitude. That means our mountain and valley, the maximum displacement must be 2. So we will have 0, start with 0, and then, okay, now normally we will mark down our maximum 1, right? And then we'll go to 2. But since this one, we just straight away draft 2. So for this one, instead of writing 1 and 2, we can straight away mark this as 2. Okay, so I hope you get what I mean. That means if you plot sine x graph, okay, you plot sine x graph, this is 1, isn't it? So you have 0, maximum 0, and then -1 as our minimum, and then back to 0. So you have this. Okay, and then if you want there's 2 sine x, so you may draw this. You may add this. That means your graph will stretch to this maximum minimum. So you have this. You will have your graph that I plot in a red dotted line. Okay, or the more direct way will be this. Okay, no need to create that. What we do is we just change this into 2 and -2. That's it. Okay, then only we mark this down, the label this, 380, 360, 180, half of it, 90, and then we have 270 here. So this is 2 sine x. Now, what about if I want y equals to sine 2x? Now, for y equals to sine 2x, that means your amplitude is 1. Okay, your amplitude is 1. And b, okay, that means you have 2 turn, 2 complete oscillation in 360 degree or 2 pi. All right, so what do we do is we just draw 2 complete oscillation. Mark this 4 quadrants, 1, 2, 3, 4, and then start 0, and then we have maximum 0, minimum, back to 0. Okay, we will have this graph. Isn't it? This is the basic sine x graph, but we don't stop here because we must have 2 such turns. It means we continue. Like if we can use the computer, we copy this whole thing and then we paste on this on the right side. So again, 4 quadrants, and then start with 0, 1, 0, -1, back to 0. So just complete another turn. Done. So we have 2 turns, 1 mountain, 1 valley for 1 turn, another mountain, another valley for another turn, and all this should be completed in 360 degrees. This is where we label. And then half of 360 is here. That will be 180. Half of the 180 is 90 here. So 270 must be here. We only label 90, 180, 270, 360. The rest is not important. Okay, just remember if it is 2x, then 2 turn in 360 degree. What about if we have y equals to sine 3x? Y equals to sine 3x. What does that mean? That means 3 turns in 360 degree. Now, if 3 turns in 360 degree, that means for 1 turn, it will be complete divided by 3, 120 degree. Okay, so let's sketch this one, a very quick one. We do not need to really label our x-axis in detail. What we do is we just mark down our 4 quadrants and then go to the how do we draw the basic graph for sine x. So start with 0, maximum, 0, minimum 0. And then let's draw this one turn. And then we got to draw 3 turns because this is 3x. So draw another 4 quadrants. Start with 0 and then maximum 0, minimum 0. So it's oscillating between 1 and -1, passing through the 0. Another complete oscillation, start with 0, go to maximum, 0, go to minimum, and turn back to 0. So now we have completed the 3x. And this 3x, okay, 1 oscillation, 2 oscillations, 3 oscillations, and all these 3 oscillations completed in 360 degrees. So over here, if you want to find 180 degrees, probably it's a bit tough. That is why I find out what is one turn. One turn is 120, and then this is 240. Okay, you can just mark this down. So that's it for the sketching. What if I add, oh, by the way, forgot, we have to mark this 1 and -1. This is 1, this is -1. Now, what if I change the question to, I want it to be 3. So what do? We draw, no need. We just change this to 3. Please use eraser, yeah? In your exam, don't slash what I did, okay? Don't slash like what I did. Just use the eraser, erase it. Okay, that means from the basic sine 3x graph, I can change to 3 sine 3x graph by changing the value of our amplitude. So that is the transformation in terms of A, B. What about C? So if I have C, I plus 1, what does that mean? That means the whole graph shift upwards by 1. Okay, so to make it easier, let's go back to the original sine x graph. So this is 1, this is -1. So the whole graph shift 1, plus 1. That means from 0, it will shift upwards to 1. From 1, it will shift upwards to 2. So all the points, the important points, okay, will change place. So what are the important points? The points that go through the 1, 0, -1, back to 0, and that's it. Okay, so then we combine it, all the points. Combine the points, you must know the basic graph for sine x, so that you will not be confused with all those points plotted. So this one will be y equals to sine 3x plus 1. So same thing applies to our cos graph. Now, what about if I have the modulus graph? Okay, the modulus graph. Let me use this one, modulus sine 2x. So modulus means positive. Whatever negative will become positive. So whatever negative value at the bottom here shall be reflected in the x-axis. So we will have this one. Everything will be reflected upwards. Then what happened to the original negative graph? We draw, I mean, we could just leave it in dotted line. Or you can just erase it completely. So that will be the y equals to sine 2x. What if on top of this modulus sine 2x, I minus 1? That means the whole graph will be shifted downwards after we modulus it. So from the 0, it becomes -1. From 1 become like this. So everything will be shifted downwards. Okay, normally I would advise you to mark down all the important points so that we will not miss out anything, or our graph will be in more order. Okay, that's it. So this will be the transformation of our trigonometry function by drawing in the graph sketching question. You have to know this in order for you to solve a more complicated question. Sometimes the question is not complicated. They just test you on the basic concept. I hope this one can help you. Watch another video which need us to apply this concept. So I'll see you in another video. Thank you.